Now we study the relation between K and lambda. So K is the conductivity and lambda is the molar conductivity. Okay. Now to consider that like that. If V is the volume of solution in centimeter cube containing 1 mole of dissolved electrolyte, therefore its electrical conductance is lambda. Okay, like that. Now, each 1 centimeter cube portion in the volume V has conductance that is K. So, each 1 centimeter cube portion, and that is volume V. 1 centimeter cube portion, the volume for that, what is that electrical conductance? K. And this conductance lambda consideration for what? The 1 mole of dissolved electrolyte in that centimeter cube solution. Therefore, total conductance of this solution is what? Total conductance of that solution is the nothing but that total conductance of that solution is nothing but molar conductivity, and therefore this molar conductivity is equal to lambda is equal to K into V. So this is for equation getting like this. Okay, this is number 1 equation. Now we have the next point, concentration of solution. Now concentration of solution is equal to what? Number of moles. Okay. Now the concentration of solution is the C into mole per liter inverse. The way of that. Again, concentration of this solution is equal to what? So number of moles and divided by volume of solution. So this number of moles C into mole liter inverse and divided by 1000 centimeter cube liter inverse. Yeah. Now liter inverse get cancelled. So what is remaining? C upon 1000 into this is mole centimeter cube, that is goes. Now centimeter cube inverse, this is we have. Okay. Now this is that concentration of solution. But we know that what is the volume of solution? So it is just a reciprocal of concentration. V is equal to 1 upon C. Therefore, this is C means for that concentration. Now V is equal to 1 upon this is concentration. Now this C we are getting this value. Now we have to do this inverse, taking reciprocal of that. So what happened? 1000 upon C, this is mole inverse and this is convert centimeter cube. Now this value of V are to put down in what equation? Value of V putting in equation 1. Now this is equation 1. Therefore, getting lambda is equal to K into this value of K into 1000 upon C. Okay, so this is the way of getting this equation. Or how to write this? Lambda is equal to 1000 into K upon C. This is the relationship between that the molar conductivity and that electrical conductivity. This is our in this equation. Okay. Now we will study the particular problem. Now read this problem. The molar conductivity of 0.05 molar BaCl2 solution at 25 degrees Celsius is 223 ohm inverse centimeter square mole inverse. What is its conductivity? Okay. Now, given is what in this problem? This is way. given is like this. Molar conductivity is denoted by this symbol lambda and is equal to what? 223 ohm inverse centimeters square mole inverse. Now, what is another given? Concentration. Concentration of solution. Solution is, which is solution? Barium chloride, BaCl2. Has solution that concentration is 0.05 molar. So that concentration will write like this. Okay. Now, we have to find out what? Conductivity. And what is the symbol for that conductivity? K. Means this you have to find out. K. Conductivity. Now, this lambda and then concentration C and this is K. Means these are the three symbols. Do you understand? In these three symbols, which is exactly relationship is present, and that we are getting a particular formula. Now, you should know this. The relationship between these three terms, and that is three term relationship is what? The molar conductivity lambda is equal to 1000 K upon C. So this is correct relationship between these three terms. Now, again, in problem, what we have to find out? Conductivity. Means only this is K. This you have to find out. Okay. Therefore, turn this formula the way of like this. Okay. K is equal to, how to turn this formula? Lambda into C. And this 1000 was that side. So divided by 1000. Okay. Now, what to put down this 12 given in that particular way of writing. Therefore, K is equal to what is the value of lambda? 223. What is the unit? Ohm inverse centimeter square mole inverse. Okay. What is C? So this is concentration 0.05 mole liter inverse upon 1000. Okay. 1000 divided by 1000, that is the particular unit is centimeter cube mole inverse. Sorry, centimeter cube liter inverse. This is the solution. Upon this is 1000. Okay. Now, therefore, you are solving this centimeter cube, this centimeter square, liter inverse. Here this liter inverse get cancelled. Okay. The way finally you are getting answer is that the lambda is equal to, after solving this problem, 0.0115, and the unit is having that ohm inverse centimeter inverse. Okay. This is the final answer. Let us will study the variation of conductivity with concentration. What is symbol? Conductivity K. Now, in general, they have given variation of conductivity with concentration is like that. The conductivity always decreases with decrease in concentration. Conductivity of solution is always decreases with decrease in concentration, that is on dilution. Means in short, K is directly proportional to the concentration of solution, that is electrolytic solution, but K is inversely proportional to, that is V, volume of solution. Okay. Means what here? The concentration of solution increases, that conductivity K increases. But volume of that solution increases, that conductivity K decreases. Basically, electrical conductance, this is that the conductivity K is nothing but the 1 centimeter cube of solution, its conductivity. That volume of solution containing 1 centimeter cube of volume of solution, and it depends upon, K depends on, or conductivity depends on that number of ions present in 1 centimeter cube solution. Okay. Now, on dilution, after dilution or on dilution, what happens here? The number of ions increases. Number of ions increases. Why? Due to the degree of dissociation. If the number of ions here increases, but what happens here? The total number of ions in 1 centimeter cube of solution, 1 centimeter cube of solution, number of ions not increasing as that proportion. So 1 centimeter cube solution, number of ions is actually decreases. Number of ions here decreases. Therefore, the number of ions decreases, the conductivity K is a. We'll study variation of molar conductivity with concentration. Molar conductivity is denoted as symbol lambda. Now, molar conductivity is the electrical conductance of 1 mole of an electrolyte in a given volume of solution. Now, 1 mole of an electrolyte is present in given volume of solution. Now, here on dilution, this given volume of solution containing 1 mole of an electrolyte, and suppose you have to dilute this solution. On dilution, number of ions increases. Therefore, number of ions is increasing, the molar conductivity is also increases. So, the molar conductivity increases with, that is on dilution. So, molar conductivity that increases with decreasing concentration means you have to the concentration decrease. On dilution means what? The given concentration you have to decrease by addition of that particular water. But due to this, actually the number of ions is increases, and we know that number of ions is increases, the molar conductivity is also increases. Now, variation of molar conductivity with concentration. Now, we have to study special in case of that, this under this headline, in case of that, the strong electrolyte and the another one is that weak electrolyte. How the molar conductivity varies with concentration in case of that, the strong electrolyte and weak electrolyte. Okay. I will see in this case first. Now, molar conductivity in strong electrolytes increases on dilution. This is the molar conductivity rapidly increases with on dilution in case of that strong electrolyte. Now, the dilution has no effect on that molar conductivity. Okay, means you have to dilute more. So, the dilution is like this, the way of that 0.001 molar or 0.001 molar. Means here, it approaches the limiting value for 0.001 molar or 0.001 molar. Now, the maximum limiting value for the molar conductivity, okay, or maximum limiting value of molar conductivity is what? Okay, the molar conductivity at 0 concentration or at infinite dilution. Such a low concentration is like what that? The infinite dilution, or this such concentration is 0 concentration. At 0 concentration or at infinite dilution, that time molar conductivity is denoted by the symbol lambda base to the 0. So, this is called as molar conductivity at infinite dilution or at zero concentration. Now, what is at infinite dilution or at zero concentration means what? The solution is so dilute. Further, molar conductivity does not changes. Molar conductivity does not increase. So, such concentration is called here zero concentration or at that infinite dilution of that particular source. Now, Molar scientists observed Molar scientist in his experiment he showed that how the strong electrolyte molar conductivity is varied with concentration. Now here molar conductivity of strong electrolyte versus the square root of that concentration. Okay. Now this, if you observe in this plot graph, so we are getting this linear curve. Okay, so this is the linear octane in that the particular is strong electrolyte. So in case of that the strong electrolyte, the graph lambda versus under root square root of that particular C is a linear. Okay. Now further the Molar scientist also obtained particular equation, and that equation lambda is equal to lambda 0 minus A into square root of that particular C. So where A is that particular constant. Now in case of that weak electrolyte, now molar conductivity of weak electrolyte is also increases on dilution. So molar conductivity of weak electrolyte rapidly increases on dilution. For concentration of 0.001 or 0.001 molar, the value of molar conductivity in case of this weak electrolyte is lower than the value of lambda 0. Okay, so in weak electrolyte, molar conductivity is lower than the lambda 0 means what? Lambda 0 means what? Molar conductivity at infinite dilution. So the molar conductivity of weak electrolyte value is lower than the molar conductivity at infinite dilution. Now for weak electrolyte, the variation of lambda versus square root of C is not linear. Now again, for strong electrolyte, the molar conductivity at infinite dilution or at zero concentration, so that molar conductivity lambda base to the 0 we can calculate in case of strong electrolyte by extrapolation method. This extrapolation method means what? Extrapolation of this lambda versus square root of that particular C. Because what? Because here we are getting this linearity. But such an extrapolation method is not applicable for calculation of that lambda base to the 0 molar conductivity at infinite dilution. In case of that weak electrolyte, we cannot calculate, we cannot use this particular method, extrapolation method. Why? Because in case of weak electrolyte doesn't approach that linearity. In case of that the lambda versus under root of that particular C are not getting linearity. Such lambda base to the 0 for weak electrolyte can calculate by using Molar's law. This is up to this here. Okay.